Welcome back to Tool Tips here. So today we are covering sockets, socket wrenches, ratchets you can call them. I just usually wind up calling them a wrench. We have the swivels, extensions, drive bits, and nuts and bolts along with adapters. So let's get started on this here. First thing we're going to do is we're going to explain this is a bolt. Most of you probably know that, but we're going to cover the basis for those who don't. And these here are three different forms of nuts. The nut will thread onto the bolt. You spin it and they go together. So your sockets, ratchets, open and box end wrenches, which aren't covered here, and many other tools are used to tighten and loosen bolts, which is really what automotive repair is about. So what we're going to go on here is we're going to show you a couple different styles of nuts and well, two bolts here I have as an example. There are different head styles also that we can consider into a future lesson if need be. So first thing with the nuts is you have a couple different styles. This is a standard nut, nothing fancy. Then we have a castle nut. This is another common one you're going to see in an automotive application. You can see the grooves in the nut here. These grooves, as you can see, it looks like a castle. Those grooves are for a cotter pin to go through, usually used on a ball joint or tie rod end. The cotter pin is going to positively lock this nut on, and it will not come off until that cotter pin is broken or something else horrendously fails. And last one is a flange nut. Now, I'm a big Ford fan, and I work on a lot of Fords, and these things are the bane of my existence. Flange nuts are designed with a built-in washer. There are ones that the nut will swivel against the washer, and there's ones where the washer is built in. This washer is completely built in, all one cast piece, all machined as one. Flange nuts are designed so when you tighten them down, this flange grips whatever you are tightening it against. That makes them pretty hard to get off, and usually wind up needing at least a breaker bar, which is right back here. So now you know the basics of nuts and bolts. Well, no basics of nuts. We'll move on to bolts. Bolts are the other end that attaches in relation with the nut. So a bolt's going to be threaded. Threads are going to match whatever size nut you have, and they have a head and a shank. The shank is the threaded part. The head is the part you would put your socket or wrench on. Many different sizes, same as the nuts. Everything from tiny little things you find on the computer to huge stuff you find on the output shaft of a, we'll say, an Eaton Fuller transmission, which just happens to be a 5-inch. So now here's a little bigger bolt in length, but the diameter is actually right about the same. I haven't actually compared these two. Nuts and bolts, you have SAE. I think that's for the Society of Automotive Engineers. Don't hold me to that one. Which is the US standard, and metric, which is everybody else on the planet. You have a couple things to consider when you're looking at nuts or bolts. Is the diameter. That is simply the diameter of the shank. And then you have thread pitch, which is when you're looking at SAE stuff, it is going to be threads per inch. So if I'd put a ruler down here, you'd see so many threads per inch. Usually 16, 32, 24 threads per inch are very common. And then that would also apply to the matching nut for that. In metric, they do it a little differently. You still have a diameter. So you'd have, instead of threads per inch, you have what is a thread pitch. So you'll see like an M810 or M1415. That is the number of millimeters from high point of one thread to high point of the other. As you can see here. High point of that thread to high point of that thread. If that's a 1.0 thread pitch, that's 1 millimeter. That's a 1.5 thread pitch, 1.5 millimeters. So there's a good basis for the metric system there for you. M815, 8 millimeter diameter, 1.5 millimeters between threads. SAE or UNC is another one you see for the American style nuts and bolts. Still pretty much the same thing. You're looking at threads per inch. How many threads per inch of shank? And diameter is still diameter, just using 3/8 instead of M8 or 8 millimeters. Now let's move on to different ways you can attach these together. Let's start with the basics here. You have sockets. So this is a socket. You have a drive end, and you have a end that's going to go onto your nut or bolt. Black sockets are typically going to be impact rated, which means you can use them with something like that little Ryobi back there, or a air operated impact, or anything else that's going to put extreme force on them. If you're using a 14-foot breaker bar, impact sockets are probably a good idea. Now you have two different socket ends. You can see right here, this has 12 points. There's actually a lot more, but we're going to cover the most common ones here, which is 6 and 12 point. 12 points are in most tool sets. You run into 12-point fasteners very rarely. However, a 12-point socket gives you two positions you can go ahead and put your bolt in at. So this is not the right size bolt, but you'll get an example. You could put it in that position there, or that position there. So you get that extra position, makes it a lot easier to get on a bolt in a hard to reach area, or a nut in a hard to reach area. My favorite is 6-point whenever possible. There are 6 points going around. That matches up with most bolts, and you can see fits pretty tightly. You're going to have very Now we're going to go on one more step, and we're going to cover drive bits or adapters. This is a Torx drive bit. I've covered Torx in the screwdrivers. If you need to reference that, you can. Either way, 6-pointed star-shaped head, tip. Actually, tip is the correct term. And you have your drive end here again. This is a 3/8 drive. You have, in the automotive industry, you're going to have a couple common drives. You're going to have your 3/8 drive. Works most stuff, I'd say an inch and under is good for a 3/8 drive. If you have like a 7/8 or 1-inch bolt, it's on like a crank pulley or something, you're probably going to want to get out at least a 1/2-inch drive. Then you have 1/4-inch drive. This is the other end. So you have a male and a female end. We'll give you a quick example here. Take them, plug them together. Now it's engaged, you're good to go. Take them apart, yank them, they come apart. If you look, you can see there's a little ball here. A little ball bearing that's machined and inset into, in this case it's an adapter, but you also find it on your wrenches, if you can see it back there. So on the inside of your socket, you either have a hole where the ball is going to line up with when you put them together, like that, or you'll have a little groove, so you can see on this one. So you have your 3/8, you have your 1/4 drive, this is a male end, and finally your 1/2-inch drive. You also have a 3/4 drive, which you can see right here, and that is simply 3/4 of an inch across, 1/2 inch across, 3/8 inch across. Most of these will translate over to something in metric. However, I'm in America, so I'm using the English system. So you have your drive bit here then. Your drive bits come in all types of stuff, Phillips, straight heads. Torques are most common with drive bits because Torques usually take a little more effort than a screwdriver will put out. Now you have extensions. Going on to extensions. Extensions just extend your reach. You can take your socket or your drive bit, put it on the end of the extension, and then put it in your related ratchet. And now your socket is out at the end of your extension. A couple different, well, extensions come in all the sizes I just said, and many more. There's a couple different styles. You mainly have a standard extension and a wobble extension. So let's get everything in frame. Back here's your standard extension. Just a square shank with a square hole. Both 3/8, so it's just an extension. Gets you out further. This one's about a 6-inch. And you have a little 3-inch here. This is different. This is a wobble. You can see how the head is tapered. That taper allows the socket to go on and move a little bit in all directions. Wobbles are not as strong. Wobbles don't get you as squarely seated on the head of the bolt. So be careful with these. I personally hate them. However, they're a necessary evil. Once in a while, you get something that's only about 5 degrees off, and your swivel, which is right here, is so ungodly loose that you just have to use a wobble. So, now we covered extensions pretty well. That's about all there is to them. We're going to move on one step, and we're going to cover swivels. Same principle as a wobble extension. There's something in your way, you need a swivel. As you can see, it rotates. Been called U-joints. I know it's the same principle as a U-joint in a car, so that might be where some of that comes from, but same. This one's a 1/2 inch again. Same shank on either end with a pivot becomes a swivel. So you have 2 pivot points, one here and one here, as you can see, and you can pivot it like that, or like that, or you can sit there and spin it like this, which you can see there's some inherent bind in this design. But if you're keeping an angle that's fairly shallow, about there or less, you won't have any problems. If you're doing a 90-degree angle, you might want to go ahead and put 2 on there and have a buddy help hold one of the extensions. So how you build something like that is, again, wrong sizes. Just use an example. Put your socket on your swivel, put your extension on, and then you take your other swivel, you put your other swivel on the end, and then your ratchet would go out here. That's how you get a 90-degree with 2 swivels. If that lines up, you can get an idea there. So you can combine all these different tools together. So now we're going to go on to adapters. Adapters come in handy, especially for the home mechanic. If you're a full-fledged professional, you usually don't need these because you have the exact setup for everything you need. But adapters go from one size, in this case 3/8, to another size, 1/2 inch, or 1/2 inch to 3/4 inch. When you're talking adapters, I actually had that one backwards. You always list the female end. You can figure out why, because it's the hole and the protrusion would be the male end, but you always list the female end first, male end second. That's because you're going from one to the other. So you're going from 3/4 inch to 1/2 inch. You're going from 3/8 to 1/4 inch. You're going from 1/2 inch to 3/8. And there's also you can get a 3/8 to 1/2. You can get a 1/2 inch to 3/4, 1/2 inch to you probably can get a 1/2 inch to 1/4. But long story short, they usually go up or down one size. So, for example, if I want to go from 1/2 inch to 1/4, I'd have to do something like that. So, you know, if you have a 1/2 inch bar and you have a, say, a 6mm socket that you need to get off, a 6mm bolt you need to get off, you have a 6mm socket that's 1/4 inch drive, that might be a feasible solution for you there. Now we're going to move one step further into wrenches, ratchets, breaker bars, and other devices to actually apply your leverage. So how these are going to work is, this is your standard ratchet. Oh, sorry. This is your standard ratchet. Has it on-off, righty-tighty, lefty-loosey setup. And some of these come labeled, most of them don't. I have some nicer blue points and snap-ons that have been labeled. This is a decent Craftsman actually, but it's not labeled. So righty-tighty, lefty-loosey, everyone knows that. You learned that in elementary school. This button here will push this little piece out, as you can see. That little piece there will eject your socket off of it. So if you take your socket, there we go. Yeah, been a while since I used this one. But your socket's on it now. It's seated well. You can see the ball in the hole. You push it, releases the ball, pushes up a little bit on this, which pushes up on the inside of the socket and allows it to come off. And if you don't push it, it don't come off. It also don't go on. So this here, you turn it, you got rotation is going to be right or left. You can see right now if I turn it to the right clockwise, it moves. So righty-tighty. Now here, turn it to the left, it moves. It's a little harder to show because it's going downhill. Let's try that way. Left, it moves. So next one, again, this is a Harbor Freight Special dual drive, 1/4 inch and 3/8 inch. Has the righty-tighty, lefty-loosey switch, and it's also got an extension. Makes it longer. Wonderful thing about these extensions is it's a little more versatile. Home mechanics, this works great because you can't have 15 different ratchets. It's just not practical. Most people have a box that sits in the back of their car. This is great for those people. You need a short little normal wrench, no problem. You need something to break something loose, there you go. You need something in between, there you go. It's got detents on the back, right there, there, a couple different spots, and you pull the collar down, and it releases the ball like on the head here. Releases a little ball that allows you to slide it. Once you lock it in, it's locked in. There's another Harbor Freight Special here, but these dual drives really come in handy, especially for the home mechanic, because you have the 1/4 inch and the 3/8. Again, the least amount of tools you can own, the least amount of money you invest in a box, and the more money you put into your car. So these you will see a lot in the home mechanic world. Same thing, righty-tighty, lefty-loosey, and again, the Harbor Freight ones do not have a detent of any sort, so just the little ball is all that will hold the socket on. This one is a Harbor Freight, again, ratchet and breaker bar. I really should have brought out something a little more expensive. However, these Harbor Freight tools, the great thing about them is, well, apparently now they're warranty in every hand tool they ever made. Which means I can take that thing, I can smash it up against a concrete block wall till I punch a hole in it, bring it back to them, and they usually take care of it. So, you know, homeowners who are working on their own cars, the Harbor Freight stuff is good enough for you. We got a Cobalt here, which is next stage up. They're pretty good. And then you have your Matco, your Snap-on. Blue Point would be about equivalent with the Cobalt because Blue Point's the lower grade Snap-on. This is a breaker bar with a swivel. Some don't have swivels, some do. This one's a ratcheting, so it'll hold in place for you. Goes to whatever angle you need. And this is also a ratcheting head, like your ratchet. So this ratcheting head, you have righty-tighty, lefty-loosey. This one you can see is clearly labeled. Lefty-loosey, righty-tighty. 1/2 inch drive again. And the black steel doesn't mean you can put your impact on this. There's nowhere to put an impact. It is hardened steel though, and hardened steel means it's going to take more use and abuse. This is a good thing to use when you're taking off that suspension bolt that might be torqued to 180 foot-pounds. One last thing that I love to mention, because I love these things, is a speed wrench. They don't work very well when you're trying to use them in midair without anything on it. But as you can see with the speed wrench, you have a handle right down here where you can grab the handle and hold it while you spin this part around in circles, and very quickly use this end, which is 3/8 drive in this case, to remove just about any loose socket. Any loose bolt. And when you're removing a loose bolt with that, it makes it very easy. It's something that if you're doing a head bolt after you've untorqued it, I always break out the speed wrench, the right size socket, and spin them all out real quick. I think we've well covered everything except engagement. So that's going to be our final point. Engagement is simply how your socket engages onto the bolt. You want to make sure you have good engagement. You want to have everything seated in there. You want to have very little play, very little movement, and you want to be able to see that you have the right size socket. There are some cases where you may get the wrong size on there. Let's go grab something like a 22. Okay, we got a 21 here. You can see it doesn't quite fit. It's loose. This is a horrible example, but I wanted to get it on camera. When you get on here, you might be getting on at an angle, and it's just enough that feels like it's going to grip, but it's not, and it'll spin. So you want to make sure you have proper engagement between the socket and your bolt. I think that's covered it. Keep watching for the next tool tips, and we'll see what we cover next. Thank you for watching.